Okay, let's do the review for similar triangles. We're going to start with the sheet 5-5R, and I'm going to do all the problems on 5-5R, and then I'm going to go back and do some of the problems from our previous worksheet, specifically, I think, the last half of the worksheet. So this is problem 1 from 5-5R. This is pretty straightforward. The main thing is that we need to add an x here, because we can't find y until we find x. And then this is our standard proportion for an altitude. Just a quick review. I'm not going to do this for every problem, but when you draw the altitude in a right triangle and you go from the right angle to the opposite side, it splits it into two pieces, and those pieces are proportional to this x, right? And we saw that there's a pattern here, and it's okay to use the pattern, which is 5 over x. Now, just to review the way we learned it, right? This 5 is the large leg, and this x here in yellow is the short leg. Okay, how do I know that? Because as I've taught you to do, you can put fake angles in here to help you. And if you put the fake angles in, don't forget right angle, linear pair. And then in the big triangle here, the large triangle, this would be 70, and this would be 20 in here, okay? So 5 here, this is across from the 70, that's the large leg, and the x is across from the 20, that's the short leg. So I did, excuse me, large leg over short leg. Okay, and this is the, the mama triangle, we call it, the medium triangle. And then this is going to be the baby, or the small triangle. Okay, so in the medium triangle, it's the large leg over the small leg. And then in this baby triangle over here, it's the large leg. The large leg is across from the 70. Okay, that's x. Over the small leg of this baby triangle, and that's across from the 20, which is over here. That's a 2. Okay, we did this one in class. I'm pretty sure everybody's got this. 10 equals x squared. We're going to square root both sides. When we square root x squared, we get x. When we square root 10, we get square root of 10. There's nothing really fancy here. Okay, so that's what x is. So I'm going to erase all of our work here on the picture. We found out x was the square root of 10. And if you want to find y, this is a right triangle, so we're going to use c squared, that's the hypotenuse, equals a squared, we'll do small side, plus b squared. Now, this one you should know already, and we could have saved ourselves a step. The square root of 10 squared is just 10. So y squared equals 4 plus 10, y squared equals 14, y equals the square root of 14. Square root of 14 actually does not simplify, so that's what we're going to leave as our final answer. What is the area of the largest triangle? Okay, so the area is the base times the height. Now, the base is not always the bottom, although this is doable. You can do it that way. But the problem with this base is we don't have a number for it. It's not too hard to get. We could do Pythagorean Theorem again. But rather than that, we're just going to stick with the numbers that we already have to save ourselves time. So in this triangle, looking at it kind of upside down, this is the base, and this is the height. Okay, remember that the base and the height have to be perpendicular from each other. So that's an altitude drawn to this base. So the area of a triangle is 1/2 the length of the base times the height. Okay, the length of the base times the height. Now the base is from here all the way across. That's 5 plus 2. A lot of people put 10 because they multiply it. It's not multiplying. You're adding 5 plus 2 for a total length of 7. And the height, of course, is this altitude, radical 10, or the length of the altitude, to be technical. And finally, I get this. Now, none of these things work together well. 7 and 1/2 is 7/2. And radicals can't be multiplied by numbers. Okay? So I end up just getting 7 radical 10 over 2. That's the nice fanciest way to write the answer, okay? 7 radical 10 over 2. Some common mistakes here. A lot of kids tend to think that if I have the 1/2 and 2 sets of parentheses, that I should distribute that. No, that's not the way it works, okay? There's no plus signs in here. You only multiply one of the numbers by 1/2. If you need to convince yourself that's true, make up any 3 numbers, like 2 times 3 times 4, multiply them together and see what you get, and see if you ended up distributing the 2, which of course you don't. And finally, the perimeter of the largest triangle. Okay, so now, actually I forgot about the perimeter. We really do need this bottom side anyway, so we could have done the area that way. So to get this bottom side, we're going to have to do another Pythagorean theorem, okay? And in this case, that's the hypotenuse. And the 2 legs are 5 plus radical 10 squared. Okay, that's because I'm using this triangle here to find that missing side. I could also use the big triangle to do it. And I'd have 7 for the hypotenuse, and I'd have radical 14, and I could find the other side. They all work out to the same answer, believe it or not. So c squared equals 25 plus 10. C squared equals 35. So c equals the square root of 35, which doesn't have anything nice about it. Okay, square root of 35. Remember, this is the square root of 14. So how do you find the perimeter? Well, the perimeter is actually pretty complicated, and it can't be simplified too well. We're going to add up 7 plus radical 14 plus radical 35. And believe it or not, that is the answer. You cannot, these are not like terms. They don't have the same square root. You can't do anything very fancy. So get used to that. That's okay. That's the perimeter of that problem. Okay, let's go to problem 2. Oh, by the way, area, sorry. We did talk about this. We need to put units squared. I want to make sure we remember that. We talked about it in class today. Units squared. You have to have units squared for tomorrow. By the way, it says solve for y. Y is equal to this. You don't have to put units here because you're solving for a variable, but, you know, if there were units, we could use them. Okay, this is the same drill again that we've always done. You drop the altitude. Now the only difference is the triangle is facing a different direction. So the proportion is x over 20 equals 20 over 12. If you need to understand y again, put your degrees in here, 20, 70, 20, 70, so you can see which sides go with it. Remember, that's not the actual angle measures. We're just using them for position. And you can understand this is large leg over small leg equals large leg over small leg of another triangle. Because when you drop the altitude of a right triangle, all 3 triangles, the original and the 2 new ones, are all similar. They're all the same angles. Okay, now, a lot of you tried to multiply 20 by 20, which is not terribly difficult, but there's no reason to when you can reduce before you do anything else. So 4 goes in there 3 times, 4 goes in there 5 times. It just saves us a big hassle, okay? When you work that out, you get x equals 100 over 3. Nothing too complicated, right? You're going to multiply both sides by 60 to get rid of everything. It'll reduce. You get 100 over 3. Okay, find the area. Well, if this is 100 over 3, and that's the height right here, so we're going to make this the base. This is the base all the way across the bottom. Well, the base is equal to 100 over 3 plus 12, but I'm not going to write 12 here, right? It's going to be equal to 12. It's really 12. But I'm going to write a different form of 12 so I get a common denominator. If you think about it, 36 over 3 is the same as 12, but it's nice because it has a denominator of 3. So I'm going to get 136 over 3. That's the base. The height is already given to us. It's right here. The height is 20. Okay? Remember that the height is perpendicular to the base, so it's perpendicular to this opposite side. So in a triangle, the altitude that's perpendicular to this base is the height. That the length of that is the height. And of course, the base is this big number. So finally, the area of a triangle is 1/2 the base times the height, which I'm going to make a fraction because I'm dealing with fractions here. Okay? Okay, same thing as before. You can reduce. You don't have to. I mean, there's a lot of... I'm going to multiply the 1/2 times the 20. That's the easiest way to do this. Okay, and that's going to give me 10. And then I'm going to multiply the 10 times this. Okay, when I do, I get 1360 over 3, which is the area. And I'm going to write units squared. And you don't have to reduce this. It's okay. I told you on tests and quizzes you can leave it in proper fractions. If you really want to see how big it was, you could always do this to get into a mixed fraction. Okay, 3 goes in here 4 times. That's 12. 16. 3 goes in there 5 times. 3 goes in there 3 times. That's 9 with a remainder of 1. So it's 1/3, right? So it's 453 and 1/3. But you can leave it improper. That's what I'm going to do because Mr. Campbell said we could, and makes things easier to deal with. Okay, in order to do the perimeter, I've got to do 2 Pythagorean theorems, which is a little bit messy and takes a little bit of time. So I've got to do Pythagorean theorem over here and a Pythagorean theorem over here. You can, by the way, set up other proportions and it will work too, but Pythagorean theorem seems to be the easiest for everybody. So let's find this. We'll call this C temporarily, right? So C squared equals 12 squared plus 20 squared. And C squared equals 144 plus 400. So C squared equals 544. Okay, these are bigger numbers than you'd have on the quiz, so it's not a big deal. And then C equals radical 544. Okay, we'd have to think about that if that reduces or not. We'd have to look at that. I'm not going to spend the time doing it here. I'm going to just do this side here. So that is C squared, that's the hypotenuse, equals 20 squared plus 100 over 3 quantity squared. Okay, and that's going to be C squared equals 400 plus, now this is kind of difficult, but it's not crazy, 100 times 100. 100 times 100 is 10,000 over 9. That denominator has to get multiplied by itself too. It's 100 over 3 times 100 over 3. It's that. A lot of mistakes there, potentially. I want to make this over 9 because I need to have a common denominator before I can add them. So I'm going to make this to be 3,600 over 9. So I change the 400. And basically, I get C squared equals a huge number here, right? So 13600. Yeah, you won't have to do this in a quiz. I mean, same problem, but you'll have much easier numbers over 9. And when we square root both sides, believe it or not, we don't really talk about this a lot, right? C equals the square root of this over the square root of 9. You can break that. See, it's one big radical, but you can do each one separately. Okay, now, it probably goes further, but let me just show you a little trick here. This is multiplied by 100, so the first thing I want to do, just to get it at least started, again, you would not have a number this big ever on a quiz. I'm going to do this, okay? And that simplifies, at least initially right away, to 10 radical 136 over 3. Because square root of 9 is 3, square root of 100 is 10. And 136 may have factors that allow you to reduce it. I don't think it does. So that's our missing side. It's a crazy number. You wouldn't get a number that big or crazy on a test. Over 3. Okay. Now what's nice is that everything is kind of over 3. So we haven't found this side yet. Oh yeah, we did. I'm sorry. Except this one is radical 544. So not going to ask you this in a test, so it's really kind of out of scope on this problem, but it would be radical 544. Now we'd have to see if that reduces or not, which we didn't do, plus 10 radical 136 over 3, plus, if you remember, the base was 136 over 3. Okay, nothing really to do here, except we have to check these two radicals to see if they reduce further. You won't have one that big on the test, so no big deal. If you got this far, I'd be very happy. These are both divided by 3, so you could make this a single fraction over 3, and we could actually put, when to be really fancy, we would put a 3 here and put it over 3 and get this entire numerator over one denominator, okay? Not a big deal. Like I said, out of scope. I wouldn't worry about that one. As long as you could get each one of these different lengths, you're good. Okay, now this guy doesn't tell you they're similar triangles, but you kind of figured out because these lines are parallel. These lines are parallel because of corresponding angles. You don't really need that. You could just say that angle A is congruent to itself, and these two angles are congruent. That's AA. So regardless, we know that triangle ADE is similar to triangle ABC. Okay? And what does that mean? That means all the sides are proportional. So let's do some proportions, right? So we don't have any information about the right side here, so we're going to ignore the right side. So we're going to do left side over left side. This is a little different than how we do it in the other triangles. You could do left side over base equals left side over base, or you could do left side over left side equals base over base, which is more common way to do it. Okay? All right, now what's the left side of, we're going to do little triangle and big triangle. What's left side of little triangle? That's 8. That's the left side of little triangle. And what's the left side of the big triangle? You might be tempted to say 4. That would be completely and utterly wrong because 4 is not part, I mean, it's part of, but it's not a length of a triangle. The length you're looking for is from here all the way to here, which is 12. Okay? So little triangle over big triangle equals little triangle's bottom or base over big triangle's base. And that's it. Okay, we're going to multiply both sides by 12x. When we do, we're going to get 8x equals 48. I know, or you know, that I don't like cross multiplying, but that's really technically what you're all doing. I like to teach it to you by multiplying both sides by 12x. The result is the same. Okay, and you get, of course, x equals 6. Okay. More typical of a test problem as far as the numbers are concerned. Okay, find EF. Find EF. Well, I'd like to set up a proportion here, but the problem is I can't even say they're similar yet, right? This looks like SAS, but over here it's ASS. So we have a real problem. I can't use any of my theorems to prove this true. There's not the same theorem for both. So I might be tempted to walk away. However, it's a right triangle. So when it's a right triangle, I can find the missing side, right? So for this first one here, of course, it's a triplet. It's 5. You should really know that triplet, but I'll say it anyway. 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. That's 25 equals c squared, or c equals 5. And this is just another version of this. This is a 6 blank 10 triangle, and that's 8. Okay, so that's what EF is 8. I just do that by Pythagorean theorem. Similar by what theorem? Well, actually, we can do SSS right now, or we could do SAS. I'm going to do SAS, which might have been your instinct. But I could have, once I found all 3 sides, I could do SSS as well. Similarity statement, first triangle in alphabetical order. Similar to triangle. Now look what happens. A is the right angle, so F has to go next. Okay. B is across from 4. Now 4 is the medium side, 3, 4, 5. Or it's the large leg, right? So B is across. So over here, what's the large leg? It's not 10, that's the hypotenuse. It's 8. And what's across from 8? D. Okay? So this is D, and of course the last letter just goes in there. Now it says find BC, which I think we already did. That was 5. Pretty easy. Okay, next problem. Similar by what theory? Well, we have vertical angles, so that's a given, but we also have corresponding angles, right? I'm sorry, alternate interior angles, not corresponding. Alternate interior angles, why? You've got parallel lines, and if you extend the parallel lines and draw one of the transversals, like this one, bam, you can just see these angles pop. These 2 purple angles pop. They're congruent. And once I have 2 angles, I don't really need to worry about the sides, so I can just say AA. Okay, and the triangle on the left is triangle XYZ, that's alphabetical, is similar to triangle. Now X is up here, that matches with W, alternate interior angles. Y is this angle, that matches with V. And of course Z is the last one. When you have vertical angles like that, you're expecting these letters to be the same, which they are. Then it says find X. Okay, well, if these are proportional triangles, right? We'll do over here, we'll do 7 is to X Okay, now 7 was across from W, and X is across from X. Oh, I'm sorry. Yeah. So the 7 is across from W. So I went across this one, and the X is across from X on this one. See, they lined up in position. Okay. Equals what? We need another proportion. So we'll do 6 to 4. Okay. So 6 and 4 are across from the same angles. In other words, 6 is across from V, which is the second position, and 4 is across from Y, which is also the second position. So we know that those sides line up together. So we multiply both sides by 4x. Let's do it that way. I haven't done that today yet, so let's do it. So we multiply both sides by 4. These reduce. This stays. You get 28x equals 6. And then you're going to multiply both sides by x, which is pretty obvious. So you're going to get 28 equals 6x. And x is not going to be even. 6 goes into 28 4 times with a remainder of 4, right? 4 times with a remainder of 4. So that's 4 6, but we want to reduce that, of course, which is 4 2/3. Okay. Okay, moving right along. 6. Aaron, who is 1.6 meters tall, casts a shadow that is 1.25 meters long. Her shadow extends to the end of the tree shadow when she stands 4.75 meters from the tree. What's the height of the tree? Okay, we've got two similar triangles. We've got a little baby triangle here. And of course, we've got the large triangle. Notice I don't overlap my lines there so I don't get too confused. So I'm going to go like underneath it. So you can see the red triangle and the purple triangle are similar. And we can do proportion, right? So we're going to do any side to any side, of course, but we'll do bottom to left side equals bottom to left side of a different triangle. So this is the red triangle. Okay, and this is the purple triangle, the big triangle. So that's the large triangle. And all right, so for the large triangle, the bottom is all of this, all of that. That's the bottom of the purple triangle. So you have to add those two up. So this is 6. Okay, 4.75 plus 1.25 is 6. The left side of the big triangle is unknown. That's what we're looking for, actually. We're going to call it H. You can call it X if you want. Okay, H. And then we did bottom left, bottom left. So in the red triangle, bottom is 1.25 and left is 1.60. Okay, now if they give you decimals like this, we're definitely going to do a calculator problem. Okay, if they give you a decimal like this, we're going to do a calculator problem, which I know I put somewhere over here. Okay, so I'll leave this one to you guys. I think you can check this pretty easily because I'm going to lose my, okay. So it's going to be 1.25h equals 6 times 1.60. That's not too hard. We can do it anyway. Right? This is if you didn't have a calculator. 9.60. And then we'll divide both sides by 1.25, right? So I'll put 1.25 into 9.60. Move the decimal place over twice. Move this decimal place over twice. Okay, 125. Actually, no, sorry. Yeah, 125 goes into 960. I think it goes in 8 times. Let's see if it does, right? 8 times 5 is 40. That's 20. I was wrong, right? Too big. Okay, that's right. So we're going to try 7 times. 7 times 5 is 35. 14, 15, 16, 17. 7, 8. Okay. And that leaves us, we're going to borrow. It's 5. And then we're going to borrow from this. 15, that leaves us with 85. Wow, that doesn't go in there. So it's 7 and 85 over 125, which does reduce. And I think that's the final answer, right? So we have to just reduce it. So 5 has to go into there, or how many times, right? 5. I know I can, yeah, I know I can reduce by 5. Let's do that. So 5 goes into 85 once. This would be a calculator problem, of course. 17. So I get 7 and 17 over, now how many times does 5 goes into 125? Right? It goes, I think you know this one, it's like 5 quarters, so it's 25. Okay, so 17/25. And that's the final answer. Nothing really complicated except at the end, if you don't have a calculator. This would be a calculator problem, though, on the test, if it was given to you in decimals. Okay? Let's go to 7. So we can find z pretty easily. This is the classic relationship we've talked about so many times. So I'm just going to write it. 8 over z equals z over 3, right? Because that's the altitude. We've talked about it many times. I don't need to show you again. 24 equals z squared. Z equals, I'm going to just switch sides here because I'm more comfortable doing that, equals the square root of 24. And of course, the square root of 24, excuse me, is 4 and 6. So I put radical 4 and radical 6. Don't just drop the radical then. Now you drop the radical, and that's our answer for z. Okay, so this is 2 radical 6. Okay, I'm going to do the other ones by Pythagorean theorem. So to get y is the hypotenuse of the baby triangle, so it's y squared equals 3 squared. Now, I could put 2 radical 6 squared, but I'm going to instead take an easier number. I'm going to put 24 up here, right? So I'm going to put square root of 24, but squared. All right, why is that so nice? Well, because now you get y squared equals 9 plus 24. It's just what it originally was way up here, see? Because it's squared equals 24. So square root of 24 and then square it, you get back to 24, right? If you square root a number and then immediately square it right after you're done, you get back to where you started from. And so this one becomes y squared equals 33. Nothing fancy here. There's not much we can do. So y is the square root of 33. Okay, and then finally we'll do Pythagorean theorem with the mama triangle. That's the medium triangle here. And we're going to do x squared equals z squared plus 8 squared. Okay, x squared equals z. Oh, did I miss? I'm sorry. Yeah, I messed up. I mean, it's true, but I messed up because we know what z is, right? Okay, my bad. X squared equals z squared. Now, z squared is 24, don't forget. 24 plus 8 squared, okay? So x equals the square root of 88. The square root of 88 is pretty an easy one. Square root of 4 times the square root of 22. And of course, that's equal to 2 radical 22. Okay? And that's what x is. So I think we found all 3 numbers pretty easily. Okay, same relationship we had before. It's just the x is this distance here. So there's a few ways to do this. I think the easiest way to do this is the Pythagorean theorem because this is a classic Pythagorean triplet, which I know you've been studying and memorizing. It's 6, 8, blank, right? So 3, 4, 5 is the normal triplet, right? That's the normal pattern of Pythagorean theorem that we don't bother solving. But 6, 8, 10 is just a double of all of those, okay? So without any work at all, I know this has to be 10, and you should too. Okay, now I'm going to set up my proportion to solve for this piece right here. This is not x, okay? So I'm actually not going to use x. I'm going to make up something for it. I'll call it w, okay? I'm going to find that red. So the proportion, of course, is 6 is to 8. I'm going from here to here, which is equal to 8 over w, not over x. X goes all the way. I'm going to find this piece, then we'll worry about what x is. Okay, so I get 6w equals 64. W equals, now 6 goes into 64. One time. It does not go into 4, and I'm left with 2/3, right? So 10 and 2/3. I said to leave it improper too if you want to, that's fine. Doesn't really, yeah, I guess 10 and 2/3 is easier to deal with in this case, okay? So that's this w, but they asked me for x. So x is the w plus this piece, which is 6. So it's basically 10 and 2/3 plus 6. So you know what I do need to do improper fraction. So we're going to take this. which is 10 times 3 is 30, plus 2 is 32 over 3, okay, plus 6 over 1. We're going to change that. We're going to make it in thirds, so it's going to be 18 over 3, because that equals 6. Okay, we're just changing it. Why? Because I'm trying to find x, and x is the addition of these two numbers, of what we found for w, and of course the 6 right over there that they gave us in the middle of in the original problem. So finally I get 50. 32 plus 18 is 50 over 3. And that's okay. You can leave it in improper form if it doesn't reduce, which it doesn't. Okay, so z is 50 over 3. And x, of course, was this number. Let me see. X was 10 2/3 plus, oh, that's what we just did. I'm sorry, plus 6. I'm sorry. So that's not z, that's what x is. We found that by adding these two. That's how we found it. Okay, and then for z, we can do Pythagorean Theorem, probably the easiest way. It's a little messy because it is a fraction, so it's not going to be pretty, but we can still do it, okay? So for Pythagorean Theorem, we're going to use this triangle here. So we're going to use, I don't really want green. We're going to use this triangle here. This is a right triangle. You know two of the sides, even though one's a fraction, which makes it messy. We're going to find the third side. Okay, so it's z squared, that's the hypotenuse, equals 8 squared plus that number we found earlier, which was 10 2/3, right? Plus 10 2/3 squared. Now that's 32/3 squared. Okay, we can deal with that. So z squared equals 64 plus, now this is nasty, so again, we probably use a calculator. I mean, I can do it really quick for you, but we'd use a calculator. 32 times 32 is 4, 6, 6, 9, which is 4, 12, 1024, okay? So 1024. Z squared equals those two added together, which is 1088. And z equals the square root of 1088. You could do a factor tree on that to see if it reduces. I am not going to give you numbers that big. So we're just going to leave it like that for now. Okay, but you do need to check to see if that can be reduced. But you won't get one that big on the test. So that's finding x and z. And of course, we found this w in order to get x. Okay, problem 9 is a good problem. It's a little tough. That's what we're going to go over it. Well, we got to look about what we have. So we have this. Now that's the hypotenuse of the biggest triangle, right, of the daddy triangle. And we also have the leg of the daddy triangle. Now again, if you use my little trick I taught you about 20, oops, I don't want that pen, sorry. I use my little trick here about 20. So we put a 20-degree mark in here, and then that's a 70 here, and then of course 90, and 20, 70 here, and 20 here. That will help us see the long leg versus the small leg. So in the big daddy triangle, in the big triangle, the biggest triangle of the whole picture, you can see that we have the hypotenuse and we have one of the legs. So we know we're going to use that triangle. So for the, for the largest triangle, we're going to do hypotenuse, which is 15, over the leg. Now, what leg is this, right? This is the hypotenuse. And this is the 5. Now, the 5 is across from the 20. In the big daddy triangle, the 5 is across from the 20. See it there? The 5 is across from 20. That 20 is the smallest angle, so that 5 is the smaller leg. So this is small leg. Okay, now we know that that proportion is equal to the exact same proportion in both of the other remaining triangles, the little tiny baby one and the medium-sized one, right? Well, the only one that has a number is the baby one. See, this baby one down here, watch as I use the highlighter here. This baby one has a known side, and that known side is 5, see? It's 5. So let me get rid of these. Oops, not those. Okay, so what do I need to do? I need to say, I know I'm going to use that triangle because the other one has nothing in it, so I'm going to use the baby triangle. Oh, that's the largest triangle. I'm going to use the baby triangle, and I'm going to have to find what? The hypotenuse. So I have to match this and the small leg of the baby triangle. Okay, well, here's the baby triangle right here. Which one's the hypotenuse, right? It's 5. It's across from the 90. And the small leg is across from the 20. See this Y right there? That's across from the 20. Just like the 5 is across from the 20 in the big triangle. Okay? So the Y is across from the 20. That's the small leg. Okay, that's my proportion. So I get 15Y equals 25. It's not going to be pretty. Y equals 25/15, which reduces. 5 goes into both of these 5 and 3 times, right? So 5/3. So Y equals 5/3. Okay. Now, to get X, we're going to have to subtract that from 15, right? So it's going to be, so X is going to be 15. That's the entire length of the hypotenuse, minus this little piece here, which is 5/3. So 15 minus 5/3 is going to give me X. Okay. Now, how do I do that? I have to change 15 to have a common denominator. So it's 45/3. It's a little sloppy there. Maybe I'll just erase it. Okay, but I'm going to change 15 to be 45/3. Remember, this whole fraction there is really 15. Okay, so it's the entire length minus Y will give me X. And that's pretty easy. It's 40/3. And again, it's okay to leave it in proper fractions. The proper fractions are so much more convenient. You can always divide it to get the improper fraction. So we have Y is 5/3. We have X is 40/3. And now we want to find Z. Okay. Probably the best thing to do is just Pythagorean theorem. We knew we could have done this way, much earlier in the problem. We didn't really need to do any of these for Z. But for X and Y, we needed to do them. So for Z, we're just going to use the very big triangle, and we're going to use Pythagorean theorem. So the very big triangle's hypotenuse is 15. Right, that's the big triangle's hypotenuse. Take a look. I'll highlight it. So we're just going to say that squared equals this squared plus this squared, right? 5 squared plus Z squared. Okay. Equals 5 squared plus Z squared. 15 squared is 225 equals 25 plus Z squared. Z squared equals 200. Radical 200 equals Z, because I square rooted both sides. And of course I can change this to radical 100, radical 10 equals Z, and finally Z equals 10 radical 10. Okay, I'm not going to fill it, well, okay, I can put it in here, it's not so bad. Okay, and that's how you find those three. So I like this problem a lot, number 9, because we had to do a slightly different proportion. And the way we figured it out is we said which triangle has 2 known sides, right? And it was the big triangle. And then which triangle has at least one other known side, and it was this little baby triangle down here. This, mama triangle here, the middle one here, I'm going to highlight it really quick. This red triangle right here, it had no numbers known to it at all. It only had letters. Well, actually, it had a bottom that had nothing on it. It had no numbers. So I'm not going to use that guy. I'm going to use the biggest triangle, which had 2 known sides, 2 numbers, and the baby triangle, which had at least 1 known side. Set up a proportion. This is the proportion right here, very important. Making sure the 2 triangles are here, and I use the exact same side comparison, hypotenuse to small leg, in both triangles, and I solve for Y. Y leads me to X, and of course Z I just found through Pythagorean theorem. So there's often going to be one letter that all you need is Pythagorean theorem. Okay, guys, I hope that helped. Good luck. See you tomorrow.